Hi class, welcome back to our lesson in General Physics 1. So this is part 2 video of our lesson 4.2. So we're able to answer the sample problem 4.2.1 in the first video, and we're going to continue on with our second problem. But before we go and read our second problem, let's understand first what is an Atwood machine. Atwood machine is a very important, it's actually the first, or it's an important machine. It's the first ever laboratory machine that is used to actually experiment on verifying Newton's three laws of motion. Using this Atwood machine, we were able to confirm that the Newtonian laws, the three laws of motion, law of inertia, law of acceleration, and law of interaction are all valid, and that's why we call them laws, because they will always be they can be applied to anything that is moving in the earth, and we can actually even use them in the movement of the planets. It is the laws and the principles we use to measure the movement and to predict the movement of the planets and a lot of things in the earth. So what it is basically a machine designed by George Atwood in 1784, which consists of two different masses connected by a string that ran over a low friction pulley. So here's a moving picture of what it actually is. So this is basically what an Atwood machine is. So you have a pulley on top. Let me just use this. So you have the pulley on top, and it's a frictionless pulley, and because it is frictionless, we can remove the mass of the pulley, because when we are solving for Newtonian laws, especially for the entire system, this is where the entire system is coming off now, we have to consider all the masses that is acting on our movement. So as you can see, the pulley is also moving. But because we created a very close frictionless pulley, we can remove the mass of this pulley, so that we are only focusing on the two masses hanging on a string. So there are two different masses. So as you can see, that one and this one right here, and they're hanging by a string. So the string they hang on is not visible, but it's there. So using this simple machine, we can actually solve and verify the Newtonian law, and that's what we did. Yeah. So given the masses of, or the value of the masses, so as long as you know the mass of these two objects right here that are hanging on the string, it is possible to predict the acceleration, tension in the string, and the position of the masses at various times. So as long as you know the mass of this object right here, you can predict their acceleration. You can even predict the tension on the string. Tension is basically the force that is being felt by the pulling of the string. Especially, halimbawa, may sinabit kayo. Halimbawa sa mga Christmas ornaments nyo, tama? Usually, yung mga Christmas ornaments has wire or strings on them. And when you hang it on a Christmas tree, the string that is attached on that Christmas ornament, yung mga Christmas balls na linalagyan nyo sa Christmas tree ninyo, there is a tension experience on that string. So we can actually solve for that tension as well, because that tension is actually a force as well. As well as we can identify kung nasa position siya. For example, at 4 seconds, at what position? Ano na yung position niya along the y-axis. And that is the kinematics part of the Atwood machine. So now that we are familiar with Atwood machine, we will use the second law of motion to solve problems regarding pulleys. Okay, regarding things that are hanging. Okay, so let's look at this sample problem of 4.2.2. Two masses, mass 1, which is 12 kilograms, and mass 2, which is 13 kilograms, are connected by a light inextensible string passing over a frictionless pulley. So as you can see, those are very important words right there. Inextensible, so meaning the strings here, sorry, the strings are inextensible. When they are inextensible, later I will explain what is happening. So the string has to be inextensible, as well as the friction should be frictionless, because if the pulley is not frictionless, we will also have to consider the mass of this pulley. Pero dahil frictionless siya, we can just remove that in our equation and create a very ideal situation na ang focus lang natin is yung mass ng dalawang nakasabit na object, which mass 1 is 12 kilograms and mass 2 is 13 kilograms. So, ang hahanapin natin ngayon is 1, yung acceleration sa buong system. After, for example, you sinabit mo siya, natatanda niyo yung picture kanina. So, if you hold one of the masses, it will stop, it will not move. But as soon as you release one of them, if one mass is heavier than the other, then it will start moving. So we start from rest, and then we release them from rest, and then they will start to move. We also have, and when they move, there is an acceleration because there is a change in velocity. The velocity from rest to movement, start moving, there is a change in acceleration, so we can solve for that acceleration. And the next thing is we can solve for the tension in the string. So tension in the string is yung force na na-experience ng object as it is hanging by a string or a wire. And also we can solve for the velocity or speed of either mass after moving at a distance of 2.4 meters. Okay, so let's look now on how we can solve this problem. Okay, so let's move here. Okay, so this is our sample problem. Okay. So we've explained kanina what is happening. So let's first write our given. So yung mga given natin, first we're given two masses, which is mass 1, and mass 1 is equals to 12 kilograms. We were also given mass 2, and mass 2 is equals to 13 kilogram. And these two are connected by a slight inextensible string. So they're connected by a string passing over a frictionless pulley. So, ang ina-ask sa atin, so we're being asked first is what is the acceleration for the entire system. So what is the acceleration happening for the entire system? B, they're also asking what is the tension experienced by the strings pulling on these objects, on these masses. And lastly, we are to solve for the speed of one of the masses at D is equals to 2.4 meters. So at D is equals to 2.4 meters, ano na yung speed. And remember, yung formula na gagamitin na pa rin natin is still the second law of second law on motion, which is F is equals to ma. Okay, so let's start with our solution. So how are we going to solve this problem? So the first thing that I want you guys to do is to create a free diagram. Kung ano yung nangyayari. So, number 1, let's create a free diagram. Okay. So, in creating a free diagram, what we're gonna do is we're gonna isolate the parts. So when we isolate the parts, dito na pumapasok kanina yung entire system and a part of a system. So this picture right here is the entire system, the pulley and the masses. If you want to create a free diagram, we can separate these. Um, we can separate the parts of this entire system. Since the pulley is frictionless, the mass of the pulley is basically non-existent. So we can just remove that because it doesn't have a mass. So we are only left with our mass 1 and our mass 2. So we can draw two masses. Okay, and this is our mass 1 and this is our mass 2. So now after drawing these, let's look at the forces acting on these two masses. So, dahil nakasabit silang dalawa, there is a force acting going in the upward direction. And this upward direction is called tension. So let's use letter T to derive or use tension. So we have tension 1 and tension 2. Moreover, there is another force acting on this object that is pulling them downward, and that is called the weight. If you guys remember, weight is equals to m1g. Weight is equals to, we have weight 2 equals to m2g. So these are all the forces acting on each of the masses. So after drawing our free body diagram, let's look on how we can solve for A, or acceleration. So before we can solve for A, there's some assumptions that we have to understand. For this type of question, wherein you have a frictionless pulley, you have a frictionless pulley and an extensible string. The tension for this kind of situations, the tension na na-experience ng mass 1 at yung tension na na-experience ng mass 2 should be equal. So, yung constant yung tension na na-experience nung string na kung saan naka-attach yung dalawang masses natin. So, tension 1 should be equal to tension 2. So, these are important assumptions to solve for acceleration. Another thing, if we look at here, since our mass 2 is heavier than our mass 1, kasi this is 13 kilograms, this is 12 kilograms. So we know that the whole system is actually moving down. Tama? So I hope you guys catch that. So our system is actually going down. So we have an acceleration that is headed in going down, and we can use that as our positive because negative. That's our positive. That is because in dynamics of translation, it's up to us kung saan yung positive and negative direction natin. So the whole system is going down kasi mas mabigat yung M2, therefore bababa siya. But if we look individually, alam natin na yung acceleration nito, there is an acceleration going down. So this is the entire system. Ito yung total, okay? So just remove the word total. Pero this is for the entire system. Moreover, we can also look at the acceleration for each of the masses. Since we know that mass 2 is going down, there is an acceleration happening for mass 2. and that acceleration is going down. And moreover, we can assume that as our positive. And also, there is an acceleration happening for mass 1. Tama? And that acceleration, since it's positive, we can use that as a negative direction because this is positive. Therefore, this direction is going in the negative. Yung assumption dito na pwede natin gamitin for this type of situation wherein it is hanging in a frictionless pulley with an extensible cord, in this type of situation, yung acceleration should actually be the same then. So the acceleration for A2 should be equal to the negative acceleration of A1. So both acceleration is equal. It's just they are in the opposite direction. Okay, so these are the assumptions that I want you guys to immediately assume on a problem like this. Okay, that the tension for both the object is equal and that the acceleration for both objects should have the same equal acceleration. And that acceleration is actually equal to the acceleration of the entire system. So how are we going to solve this? Okay, so to solve this for acceleration, after having these assumptions, let's now look at forces acting on mass 1. Okay, so for mass 1, we have to use F is equals to M mass 1 A. We're just gonna use A because A2 and M2 are just the same lang naman. It's just the direction, the negative sign. Okay, so let's just use F is equals to M1 A. That is the force that is to identify the force that are acting. Let's look at the net force. So going back to our free body diagram, one of the force that is acting is our T. So we have our tension. So the forces acting is T, and the other force acting is weight. Okay, it's so you have the force acting on our mass 1 is tension and weight 1. Therefore, this T and weight 1 is actually in the F. Now let's look at the direction of the movement nung mass 1 natin. Okay. Just a second, let me look up my notes. Okay. Okay. So in this situation, we have our tension and weight. So we can have tension and weight is equals to our M1A. When you have a situation like this, na yung free diagram mo, let's write our free diagram here. So for mass 1, where you have your T here and you have your weight 1, and the direction of movement is going up. Ang mangyayari dito, yung configuration ng T and weight 1 mo should be T minus weight 1 if it is going towards the T, the tension's direction. Okay, so ang gagawin mo dito, T minus weight 1 is equals to M1A. Okay, and we know that a, let's rewrite this, weight 1 is equals to m1a. Okay, so we know that m1 or weight 1 is equals to m1g. So we're gonna have t minus m1g is equals to m1a. Okay, so m1g is equals to weight 1. Ito lang yon. I just substituted the value of weight to m1g. And now we can have our this we can have this as our first equation to remember. So let's have this our first equation. So equation number 1. Okay, now let's look at forces acting on M2. The same thing, you know, we have to use F is equals to M2A. Okay, and we know there are forces which is T and weight 2. If we look at the free diagram ng mass 2, we also have the tension here and we also have the weight 2 going down, pero yung acceleration niya is pababa. In this type of situation, ang mangyayari, ang gagawin mong positive is yung weight 2. So you have weight 2 minus T. So that would be ang force mo, which are the tension and the weight. Ang mangyayari dito sa force, it will change to weight 2 minus T is equals to M2A. Okay, so magkaiba sila dahil sa direction ng free diagram mo. Now we can switch this to M2G minus T is equals to M2A. Now let's substitute, let's rearrange this equation. So we are, that's T, na magiging equal lahat sila sa T. That's T is equals to basically negative, yeah, that is, so that would be M2G minus M2A. So that is our equation number 2. I hope that is clear on what is happening. So yung F naging W and T because this T and W are forces. And F, remember, F is a net force. So it is the sum of all the forces acting on the mass. And the only forces acting sa mass to natin is tension and weight 2. Yung magiging configuration niya is weight 2 minus T because ang movement is pababa. So yung magiging positive basically natin is W2 and magiging negative is T. Same thing here, yung mass natin, pumupunta siya sa pataas. So yung tension, gagawin natin siya positive, yung weight ang magiging negative. So, and again, this T and F are the forces acting on mass 1. So yung F naging T minus W1 is equals to M1A. Okay, to solve for acceleration, ngayon, how can we solve for acceleration? To solve for acceleration, what we have to do is to equate both sides. Since T is equals, T1 is equals to T2, remember? So this is basically T1 and T2. We can equate both sides. So mangyayari, we have, I did not equate this. So this is basically, equation natin dito is basically T is equals to m1a plus m1g. So you have our equation T is equals to m1a plus m1g, and you have T is equals to m2g minus m2a. So mangyari, we can equate this. That would give us m1a plus m1g is equals to m2g minus m2a. Okay, so after this, ang gagawin natin, we're gonna kind of like isolate both sides. So pagsasamahin natin yung dalawang a on both sides, pagsasamahin natin yung g on both sides. This is just basic algebra, so that would give us m1a plus, because this is negative, so plus m2a is equals to, lalagay natin ito sa kabila, m1g minus, this is supposed to be m2, sorry, m2g minus, yeah, it should be minus m1g. Okay, so ngayon ang gagawin natin is we're gonna separate, we're gonna pull apart yung a, so that would give us a is m1 plus m2. We can do that kasi basically this is actually equal dun sa taas na to. We substitute a is equals to m1, or a multiplied by m1 plus a multiplied by m2. So we just remove a. The same thing we can do here. So that's g is equals to m2 minus m1. Now we can solve for the acceleration. We just have to divide both sides by m1 plus m2, and same thing, m1 plus m2. So this whole thing is cancelled, so you are left with a is equals to m2 minus m1 divided by m1 plus m2g. Okay, so now you have an equation for g. And what's good thing about this equation is applicable on any situations concerning this type of problem. So kahit palit-palitan naman yung mass na to, just use this and you are good to go. So just remember this, for this type of problem, you can always solve for mass. So now let's solve for the mass on this problem. So A, we have mass 2, which is 13 kilograms, minus mass 1, which is 12 kilograms, divided by, we have m1, which is 12 kilograms, plus m2, which is 13 kilograms, and multiplied by g. Ang g natin is just, we're gonna use positive here, meters per second squared. Okay, so now let's just move this towards this direction. Okay, so your a is actually, just solve that in your equation. Your a is equal to 0.392 meters per second squared. So that is your a. And again, this equation is applicable on any problem na may Atwood na yung situation is yung katulad dun sa problem natin. So this is a very universal equation to use when you deal with some Atwood problem. So sa mga homework ninyo na merong ganitong klaseng problem, you can use this to solve for acceleration. Now let's solve for tension. So how can we solve for tension? We have to use the two equations na nakuha natin. So the two equations that we have, equation 2, so we have T is equals to M1A plus M1G, and our equation 1 kanina, sorry, this should be 1 pala. And our equation 2 kanina na nakuha natin is this T is equals to M2G minus M2A. Okay, so how can we solve for the tension? Ang gagamitin natin is rearrange both to equal to A. So, rearrange natin yung equation 1. Ang magiging mangyayari sa equation 1 natin, magpapalit siya into basically A is equals to T minus M1G divided by, that's M1. Tama? So, you just rearrange this na maging equal siya sa A. So, sa equation 2 natin, A is equals to, basically that's T minus M2G divided by negative, because that's a negative there, negative M2. So you have your two equation. And remember yung assumption natin? Our assumption is that A1 is equals to A2. I'll bet yung isa is negative sign. Okay, so mangyari lang, we do not need to worry about the negative sign. We just have to equate both sides. So that is equals to T is equals to M1G divided by M1 is equals to T minus M2G divided by negative M2. Okay, so now we can solve for T. We can rearrange the equation so we can solve for T. Okay, so we multiplied both sides. So simple math, algebra. So that would give us negative M2 multiplied by T minus M1G is equals to M1 multiplied by T M2G. So that is negative MT, negative M2T plus M2 M1G is equals to M1T minus M1 M2G. Okay, and then we put, so we place this on both sides, so that would give us basically M1T plus, I just put it there, M1T plus, well, that's supposed to be M2T is equals to M21G plus M1 M2G. Okay, and then we can, again, yung ginawa natin sa A kanina, we can pull out T, and that would give us M1 plus M2 is equals to, you can pull out G M2 M1 plus m1 m2. Okay, and then you can solve for tension. That's m1 plus m2 divided by m1 plus m2. You can cancel this, and that would give you an equation to solve for tension. And similarly sa acceleration, you can use this on any problem relating to Atwood problem similar to our problem. So that will give you m2 m1 multiplied plus m1 m2 divided by m1 plus m2 g. So you have our equation for tension. Now we can solve for the tension in the problem. So that's m2, that's 13 kilogram multiplied by 12 kilogram plus 12 kilogram multiplied by 13 kilogram divided by 12 kg plus 13 kg multiplied by 9.8. Okay, and makukuha ninyo is actually equal to T is equals to 122.3 newtons. Okay, so now we have our acceleration and we have our tension. So that's how you solve for acceleration and tension. So hindi nyo na kailangan gawin kung ano yung ginawa ko. You just use this. Just use these equations na pinakita ko sa inyo, because these are very applicable to any problem that has an Atwood na kaparehas ng sample problem natin. And lastly, sorry, I don't intend to move that. And lastly, let's solve for C. For C, what we're looking for is the speed at when the distance is equals to 2.4 meter. So how can we solve this? So when we're solving for speed, we are looking for the velocity. So we have velocity at 2.4 meters. So if you guys look at the problem here, meron siyang word dito that I hope you guys are already familiar. There's a word here. Find the acceleration of the system when it was released from rest. So there's again the word rest, and our rest so means our initial velocity is 0 meters per second. So we have that. Now we can solve for our velocity. Since alam natin na yung initial velocity natin is 0 meters per second. And we have two equations that we can use to solve for speed. So we can use velocity is equals to acceleration is equals to Vf minus Vo divided by T. Pero we cannot use this kasi we do not have time. So this is a no-no. We cannot use this because we do not know time. But what we have is distance. So we have a displacement. So we can use 2AD is equals to V initial or V final squared minus V initial squared, or we can also use D is equals to VOT plus 1/2 AT squared. Again, we cannot use this kasi wala tayong T. So, ang equation na walang T is yung itong equation na to. So, let's use this kasi we have T naman. And what we're looking for is the final velocity. Okay? So, we're gonna use 2AD is equals to VF squared minus V0 squared. Since we know that the initial velocity is 0, let's just remove that. So we are left with 2AD is equals to VF squared. So to solve for the final velocity, that's basically the square root of 2AD, and that is equals to the square root of 2. Yung acceleration natin na nasolve kanina, 0.392 multiplied by d, that is given 2.4 meters. And we know that the velocity at 2.4 meters is actually equal to 1.4 meters per second. Okay, so that is how we finish this sample problem. So when you solve sample problem like this, where you have a frictionless pulley and an extensible cord, and they're just hanging off a pulley, one mass on each end of the string, just use these equations right here, and you can solve for acceleration and you can solve for t for any masses as long na yung situation ng Atwood ninyo is ganito. Okay, so I hope I know it can get confusing, pero I hope it is clear. If you guys have any questions po regarding this problem, do not hesitate to message me po. Thank you guys and have a good day po.